All right, welcome back to Rock the JVM. This is Daniel, and you are watching part 2 of the ZIO HTTP tutorial. In the previous video, we defined some ZIO HTTP applications, and we discussed middlewares. That is how to add some additional logic on your ZIO HTTP applications. All right, now let me take a look at the thing that we built in the previous part so that you're familiar with what we are building upon. So I have a ZIO application, which is ZIO app default, which exposes a port which is 9000 in this case. I defined two endpoints, which is a method get at /owls, coming from a meme in the internet, and we named our blog post the rest of the owl, if you know what I mean. And then we exposed this endpoint at /owls with responding with a text, exposing another endpoint at post/owls with a collect ZIO. So I showed you how you can say HTTP collect and collect ZIO with partial functions returning effects or plain values. Showed you how to combine ZIO applications defining a part of your endpoints that you want to support. I showed you how you can add middlewares, which is a piece of logic that you can use to wrap an existing HTTP application either to process requests or to process responses or both. So I showed you how you can use an existing middleware from ZIO HTTP, or you can write your own. All right. How you can build an HTTP program, which is a ZIO effect that you can later run in your application. How, of course, to build your own middleware logic. All right. Now, in this part, I want to show you some more advanced features of ZIO HTTP. And in particular, I'm going to show you CORS, which is quite popular if you want to create your own website. And this is called cross-origin resource sharing, and also cross-site request forgery, so CSRF. These two are very important if you have a data/content intensive website. And if it just so happens that you want to build that on top of ZIO HTTP, then you'll have to deal with these. All right, let's take them in turn. So CORS, cross-origin resource sharing. What is that? It's a mechanism to allow websites to allow traffic from other origins. So for example, if you have rockthejvm.com, without any CORS config, then somebody at youtube.com may issue automatic requests to rockthejvm.com and bring whatever videos I have on Rock the JVM and automatically add them to YouTube or something like that. So somebody might crawl my website, and whenever you enter their website, they actually request my website for whatever content I might have there, which is not really that great because you end up paying for all the traffic. You get to pay for all the data traffic and so on and so forth. So CORS is quite useful to have for pretty much any website. So CORS can help you block requests from other websites. Now, in addition to that, CORS can also help you with verifying that you can interact with the server at all. So, for example, if Rock the JVM was a platform where each user might be able to upload their own videos or pictures or something like that, you would be very wise to add the capability of Rock the JVM to support some pre-flight requests so that you know for a fact that you can add some sort of resources to Rock the JVM from some other resource. And if rockthejvm.com denies you that, then it's no point uploading videos or pictures or data-heavy resources to Rock the JVM because the website doesn't allow that. So let me show you how that works. So I'm going to define a val, let's call this CORS config, as CORS config with a capital C everywhere. So CORS config, this is a plain data structure, and you can have a bunch of flags here defined in the CORS config. I'm going to use any origin equals false. We have any method as false, and very importantly, we will allow certain origins. So allowed origins, I'm going to pass a function that say s equals localhost. So any other website other than localhost will be denied from Rock the JVM. And allowed methods, let me add a comma here because otherwise the Scala compiler will be unhappy with me. Allowed methods, this is going to be an option, and I'm going to have a sum with a set. So a set with method.get and method.post, for instance. Any other method will be denied. So from a browser, if you want to access our little web server here at localhost, you will be able to do that. But if you want to call localhost from another website, you won't be able to do that. Okay. Now, this CORS config thing can be wrapped in a middleware as we described in the previous part. So I'm going to have, let's say, I'm going to put that on top of the HTTP program. And I'm going to have my CORS enabled HTTP as the combined HTTP application, which I defined earlier, combined, and I'm going to use the operator middleware.CORS with this CORS config. So CORS config. Now you can obviously add multiple middlewares. So for example, I can add the verbose log that I added in the previous part. And we can also add the middleware.CORS. And I'm going to use this CORS enable HTTP here in my HTTP program. And I'm going to restart the application. Let's see what happens. All right, so we have localhost 9000. Cool. Now, let me get back to my terminal, and I'm going to use an HTTP GET at localhost 9000 /owls. Okay. Now, in this case, we get the request, which is accept encoding and so on and so forth, that we saw in the previous part. But I'm going to also add an HTTP header in the request. So I'm going to have HTTP GET on localhost 9000 /owls. And I'm going to have, in between single quotes, I'm going to have my header pairs. I'm going to say origin, colon, let's say, rockthejvm.com tries to access a resource from localhost. And I think this is me being stupid, so I'm going to have my origin rockthejvm.com after the URL itself. All right, so we have hello owls. Now, if you take a look at the headers for both the requests and the responses, nothing has changed from the original HTTP request by just getting localhost with no origin. So if you set an origin that's unknown or set no origin at all, you'll pretty much get the same kind of behavior. What this means is that if you navigate to rockthejvm.com and the JavaScript on rockthejvm.com tries to fetch this resource from localhost, the browser will block this request. That's what it means. Now, let's try a different kind of origin, which is included in this little set. So I'm going to issue the same kind of request, so get localhost 9000 owls, and then I'm going to say origin is localhost. Now, notice that in this case, we get some extra headers. So access control, allow credentials, and so on and so forth. These are CORS headers, which means that the browser would allow this request. Now, in theory, we should be able to see these headers in the logger, but I don't see them anywhere because the verbose log is in between, so we can add it at the end to wrap all the headers returned by middleware CORS. Let me restart the application and let's try this again. Maybe we'll see the CORS headers here in the console as well. Let's try this one again. All right, so at this point, notice that we get the CORS headers. So notice that the order of middlewares also matters in this case. Cool. Now, the more complicated thing is CSRF. CSRF is cross-site request forgery. What does that mean? Let's say that you're logged in, to some sort of website, maybe it's your online banking or online store. Let's have a slightly more benign use case. So logged into an online store. Now, you also have a browser plugin, and the browser plugin will issue or will change the HTML on your page to display a button. When you click that button, this will trigger a form submission, because you're logged into the online store, so the browser plugin might log your username and password. And when you click that button, let's say, I don't know, check out this new offer on the online store, the browser plugin will trigger a form submission to the original online store, for example, to change your email address. And this form submission is hidden because you can issue an HTTP request without actually displaying the form, of course. So without you knowing, this browser plugin changed the account which has, for example, some credit card data already stored. And this is problematic. So this vulnerability is due to the fact that you're logged into an online store, somebody or the JavaScript of the page itself, the online store itself is malicious, so it stores your username and password. And the JavaScript, when you do something or at a certain point, it will trigger a form submission to change the username and password associated to your account, except, of course, your credit card details, and you end up locked out of your account. This is the situation for which CSRF adds an additional protection. So really good websites will have the CSRF protection in place with a mechanism called a CSRF token plus a cookie. This is called the double cookie or the double submit cookie approach. So double submit cookie. That means that whenever you want to do something with your account, you need to also send this little token and the cookie that the website gives you back when you logged in the first place. And these two must match so that you might end up calling some endpoint associated to your account so that other malicious code, for example, a JavaScript that is from a browser plugin or an external website, might not forge requests such as a form submission without these two already set, which they have no way of checking unless you are a real user logged into a real website. Now, there are whole books written on this subject, and I explained that in 30 seconds, so I hope that makes sense. And I'm going to show you how you can enable CSRF for a ZIO HTTP application. The way that you can enable CSRF is to add another middleware, so in the same style as we did in the previous parts. So I'm going to show you how you can have a CSRF generation and validation in some HTTP endpoints. So for example, I'm going to decorate the first application with a middleware and you have a CSRF generate. And I'm going to define this other Z application with add middleware.csrf validate. So this will generate the token that you need to save as a cookie, and the middleware CSRF validate will then check whether those two are set and equal. So let's run this to see how it works. And I'm simply running this application because the combined application is app plus zapp, so these two combined. And then the combined is wrapped in middleware CORS and then under verbose log. So we will see all the HTTP headers for both requests and responses in our console. Okay, so let's interact and inspect these endpoints via our little HTTP application. So I'm going to say HTTP get at localhost 9000/owls. And notice that we have a cookie header, which is set cookie, which a browser would happily store locally. So X CSRF token is this little thing. All right. Now, if you want to ask the Z application for the other endpoint, method.post/owls, then you need to set your cookie to exactly this value and also the HTTP header XCSRF token to exactly this value so that the endpoint will reply back with the 200 OK. So let me try to access our post endpoint. So I'm going to have HTTP post, and I'm going to have localhost 9000/owls. And notice that we have a forbidden. It's a 4 or 3 because we have CSRF activated. Now, in order for this endpoint, the post endpoint at 9000/owls to work, we need the cookie and the token itself. So I'm going to have HTTP post 9000/owls, and I need the header, which is x-CSRF token. I'm actually going to copy that. So x-CSRF token is this thing. Okay, so the header itself. And I'm also going to have the cookie itself. So I'm going to say cookie x-CSRF token equals this little thing. So this argument is available under HTTP. You can also do that with curl. I'm also going to show that to you. And apparently I have forbidden. I think I've mistyped the syntax. I need a colon here. So XCSRF token is the header name, and this is the header value. Hopefully this one works. All right, so we have a 200 OK, and the endpoint works as before. So notice that we have CSRF token and also the cookie that's set by the HTTP request. So the CSRF token with the double submit cookie mechanism will ensure that no third party will be able to access your endpoint unless it has somehow access to both the cookie and the token that the website initially generated. All right, cool. So that was CORS and CSRF. Now, the next thing I want to show you is authentication. And I'm going to cover just basic authentication with usernames and password. HTTP, ZIO HTTP will support various forms of authentication, but I'm going to show you how authentication works with some plain username and password. So let me go at the top, and I'm going to define, let's call this auth app. This is going to be same kind of UHTTP application. And I'm going to use http.collect, not collect ZIO, so simply collect because I'm going to return some plain values. And I'm going to have collect requests. And I'm going to add a partial function. So in case I get a method.get, and I'm going to associate that to the path root and then slash, and then I'm going to say secret and then slash owls. I'm going to return a response. So response.text. And I'm going to say the password is rock the JVM or something like that. Okay. Now, this auth application, I'm going to decorate that with a middleware. So I'm going to have at middleware.basic auth, and there are a variety of basic auths here. I'm simply going to use a basic auth with a particular username and a particular password. The most complex or the most general basic authentication is basic auth ZIO, which receives some credentials, and it runs an effect returning a boolean whether those credentials are appropriate. So this is the place for using a database, for example, where you can hash passwords and so on and so forth. So this is the most general basic auth ZIO that you can use. I'm only going to use the very easy one, basic auth with username and password, and I'm going to say Daniel, and the password is obviously rock the JVM or something like that, or rock the JVM 1 exclamation mark with a capital R, so that we can satisfy the usual request for passwords. All right, now I'm going to use this auth application independently here under the HTTP program. So I'm going to remove the CORS and I'm going to use this auth app just to show you how this thing works. So I'm going to run this application. And we now only have a single endpoint at method get /secret/owls, which is what I'm going to exploit here. So I'm going to say HTTP get at localhost/secret/owls. And I'm going to get a 401 unauthorized because I haven't supplied any username and password. So I'm going to say HTTP, I'm going to say -a, and I'm going to have my Daniel rock the JVM 1 exclamation mark combination, and then I'm going to say get localhost secret owls. If I remove get, I'm still going to issue a get request. I think for curl, you have --user with the same kind of format. And notice that in this case, we have a 200 OK because the authentication was successful. Now, this is the place where you can create a middleware with the basic auth, and the validation, the credential validation is its own logic. So you can have credentials, and then you can have some ZIO that returns true. So for example, ZIO succeed true. This will, and right now the IDE is unhappy with me because it's called basic auth ZIO. So for any credentials, you will return true, but obviously you will change logic here to interact with your own database, with your own password validation, and so on and so forth. All right. So I'm going to simply revert back to my basic auth with Daniel and rock the JVM 1 because I've already made the point. Now, one problem that might arise with defining the HTTP application piecemeal like this is that you now have to take very good care how you want to order these endpoints. For example, let me assume that I'm going to put auth app at the top. So auth app comes first. If that is the case, then every endpoint needs to be authenticated because if the auth app doesn't respond with the basic auth, so if the authentication fails for auth app, then these two are not taken into account anymore. So for example, let me rerun this application with this combination. So auth app comes first, and then app, and then Z app. So let's run this. And I'm going to obviously try to log in. So the login works correctly with Daniel and Rock the JVM.1. And if I do HTTP GET at localhost 9000/hours, which was my basic endpoint, I get an unauthorized because the auth app comes first. The first is the validation, and then the other endpoints will only succeed if the authentication was successful. So that's not right. If I put auth app at the end, so if I put auth app at the very end, then the CSRF validation will not take place because auth app doesn't take in any CSRF tokens into account. So that will also fail. So the way that we need to put that is in the middle between the CSRF generation and the CSRF validation. So be really careful about the order of routes, especially if you use authentication and other forms of middleware, for example, CSRF. All right. Cool. Now, one last thing that I wanted to show you for this little tutorial on ZIO HTTP is WebSockets. So WebSockets, the authentication came before, so I'm going to have my authentication here, and then the CSRF, I'm going to add it at the top. So this is going to be CSRF validation and CSRF generation. And now I'm going to talk to you about WebSockets. Cool. So WebSockets are also created using the same HTTP construct, but instead of collecting requests, we typically collect something called WebSocket channel events. So communication will happen over this channel, and instead of returning responses, which are HTTP responses, we will return unit. Now, at a lower level, we are going to use a channel, which will allow some arbitrary sending of messages of a particular type. So if I type in channel event, I think this is built in from ZIO HTTP. This channel event is a case class which takes an input of type A and returns a value of type B. Now, all WebSockets or WebSocket messages are instances of these channel events. I'm going to show them to you shortly. So let me define a little program. I'm going to call this sarcastic, which is a function from string to string that just issues responses based on some sort of input. And let's say I'm going to have text, and I'm going to say text to list, and I'm going to say zip with index. So I'm going to split that by characters, and then I'm going to map that. And in case we get a character and an index, then if the index mod 2 is equal to 0, I'm going to turn that into an upper character. So c.to upper. Otherwise, c.to lower. So I'm going to type in mixed cases, and then I'm going to make string back. So make string. All right, so depending on the input string, I'm going to turn that into upper and lower characters depending on the index of that particular character built out of these characters piece by piece. Cool. Let me define my WebSocket logic. So WebSocket logic. This is an HTTP, and this will have any and throwable as the first types. Now, the input type is WebSocket channel event. So WebSocket channel event that I need to import. So I'm going to import that from ZIO HTTP, and the final output is going to be unit. Now, I'm going to use the same HTTP construct that I did for the server. So I'm going to say HTTP collect ZIO for these events, so WebSocket channel event. And then I can add a partial function. So in case we get a channel event with a channel and the event that I'm going to use as channel red. Now, the channel red is a particular kind of event, and the message is of type WebSocket frame dot text with a particular message. So WebSocket frame is actually the companion object. I think I haven't imported the right thing, not from Netty. I need to import that from ZIO HTTP. All right. So WebSocket frame.text with a message. So notice that the structure here is a little bit more complicated. Now, I need to use this channel to push a new output back. So I'm going to say channel.write and flush. And then I'm going to process a new text message. So I'm going to say WebSocket frame dot text. I'm going to use text with a lower cap t because the text thing is a factory method. And I'm going to pass a new string based on this message, and I'm going to invoke this sarcastic function over that. So sarcastic invoked on message. So essentially what this says is that as soon as I get a message as a WebSocket, I'm going to push a new message back to the WebSocket. Okay. Now, in case we get a channel event with channel and a different kind of event, for example, user event triggered. User event triggered is a different kind of event that can be created as a WebSocket. I'm going to run a pattern match on that. So event match. And user event is usually a handshake from the protocol of the WebSocket. So I'm going to have to match a case for handshake complete. And I'm going to invoke and import that. So I'm going to say user event, and I'm going to import everything here. Cool. So in case I get a handshake complete, then the WebSocket is established. So I'm going to say ZIO.loginfo. Then I'm going to say WebSocket started. Now, ZIO loginfo can be replaced easily with console println. So console.println, WebSocket started. And then in case we get handshake timeout, then I'm going to say console.println with connection failed. So you need to also trigger this user trigger event. So this is these are ZIO's returning unit, which is okay. Now I'm going to eliminate the channel because I don't need that. And in case I get a channel event with a different kind of event, which is channel, I think it's called unregistered. This means that the user has stopped the channel. So I'm going to have a console println. So console.println. Then I'm going to say connection closed. Okay, so this is the WebSocket logic that will trigger all the content and the so-called WebSocket related events. So I'm going to eliminate the channel here. And I'm going to define a WebSocket application. Let's call this WebSocket app as http.collectZIO. And collectZIO, I'm going to instantiate this WebSocket logic as soon as somebody tries to access a particular path. So collectZIO with request. So somebody will try to issue a GET request on a particular path. So in case we get a method.get associated to the root, let's say /@ws or socket or talk or chat or something like that, I'm going to start this WebSocket logic. So I'm going to say WebSocket logic, and I'm going to say to socket app, and then to response. And this is a ZIO. All right. So this is a ZIO issuing responses. All right. Cool. Now, this is a new HTTP application, so I'm going to use that as server.start so that we can test that. And I'm going to show you how you can use that. So let me rerun the application. And for this example, I'm going to use another application which is called Websocket. I'm going to attach a link to Websocket GitHub in the description. And I'm going to have Websocket, and I'm going to prefix that to ws// so this is the protocol, localhost 9000/chat. And notice that at this point, the WebSocket has started, and notice the application's console says WebSocket started. So I'm going to say hello. Notice that the WebSocket replies with hello with mixed cases. The console doesn't print anything. How is sarcasm going? And notice that WebSocket is funny. Okay, cool. So I think you got the idea. All right, folks, so this was a pretty comprehensive introduction to ZIO HTTP. I hope you found this valuable. If you did, go ahead and click the like button for me and subscribe to the Rock the JVM channel for more videos like this. Check me out on LinkedIn and Twitter. I post fresh updates on upcoming material. And check out the Rock the JVM website, as I have literally hundreds of hours and tens of thousands of lines of code on camera on everything in the Scala ecosystem. So until next time, folks, I'm Daniel, signing off.